All right, so we're looking at the skunk thing. If I was going to look at the skunk problem, and if you're just seeing this for the first time, pause it, take a look at it, think it over. But we got to think about if we're trying to analyze velocity, that's an important thing to keep in mind. We're not trying to find speed. And if we're not trying to find speed, we don't care about distance. And if we don't care about distance, then that means I don't care how long these curves are. Because if I'm trying to find velocity, remember, velocity, oh, I'll get it on camera, velocity is equal to displacement over time. And displacement is how far and in what direction it is from one point to another point. So I'm thinking about what was my displacement from I to A? What was my displacement from A to B? What was my displacement from B to C? And you notice that I, A, B, and C strategically are all on the same line. And if this was a skunk wandering a neighborhood, that means that I, A, B, and C were all on the same street, right? And that I know from the skunks around my neighborhood, they wander in the backyard, they look for grubs and whatever in the lawn, but really they're hoping that people leave out their green bin stuff in front of their house.
Drugs?
Grubs, like the little beetle larvae in the grass is what they're really hoping for. That's what they, historically have looked for, but now they look for green bins because it's a lot more fruitful, right? To go and find our organic waste. Anyway, there are opportunistic feeders. But if I was thinking about having an organizer, I might say, okay, from I to A, from A to B, from B to C, and there's nothing truly formal about this. This is just like trying to think out a problem that I've never seen before. I might say, okay, well, it seems to me that if I have like a reference frame for this situation, maybe I could have like a north, south, east, and west kind of reference frame. I might make east be positive and west be negative. It looks like if they're all going to travel along the same straight line, I don't have to worry too much about the north and south. But let's just say that each square was, what do you think, 100 meters? Does that seem like a reasonable amount? So let's just play a bit of pretend. Let's let one square equal 100 meters, just for scale. We can say, okay, well, it looks like that if I did this as like a time scale, let's let delta t for each one of these guys be 10 seconds. Again, let's just say that each one of these guys was snapshotted an equal amount of time apart. And obviously 10 seconds is a little on the short side for a skunk wandering, but it'll make the numbers all nice and round, right? We're just trying to approach this problem with what little information we've been given. And if that's the case, then it looks like from I to A, I would have gone 100 meters in 10 seconds. But it wouldn't just be 100 meters, because west is negative. It would be negative 100 meters. Look, from I to A. And then from A to B, I would have gone 100, 200. Looks like positive 200 meters. If each of these paths took the same amount of time, we'll just say like this nice round value of 10 seconds, just for brainstorming purposes. But then it went from B to C, and it also went 200 meters. In let's just say 10 seconds. And I think to myself, well, if I was trying to rank what the velocities were for these things, it looks like this one would be, well, 100 divided by 10, negative 10 meters per second, positive 20 meters per second, positive 20 meters per second. It looks like A to B and B to C are tied. You see that? If I'm just ranking these things. And I to A is negative and smaller. And the only reason we're really spending time on this is to draw attention to the difference between distance and displacement and how velocity relates to displacement, not distance. When I look at this, if I want to do a speed calculation, wouldn't I have to figure out how long these curves are? That actually becomes a lot more challenging. And I think about like, what kind of tools would I use? How would you figure out the length of a curve? Anybody got any ideas? Anybody? What if I threw it out there? What if I gave you some thread? What would you do with a piece of thread?
Arrange it into that shape.
What's that?
Arrange it into that shape.
Yeah. Arrange it into that shape, and then after you were done, couldn't you just like pull it out straight and measure it? So we could like approach things in that way, but that's not what's being asked, okay? And that's why we use things like measuring tape. That's why we use string when we're doing construction jobs or whatever. Sometimes things aren't in a straight line, but in this case, it's just displacement we're looking for. I want to take a look quickly at the next page. And I want to give you folks some time to try this again. You tried the skunk thing with partners. I want you to try this next thing with partners. On this page, I have literally stolen this from a textbook. I'll zoom out a little bit. I don't even remember which textbook it was. But I've got a graph that's similar to the one that we looked at earlier in the lesson. And whoever produced this graph already produced two tangents. Now, my criticism of these two tangents, anybody want to guess what I don't like about them?
Not the longest path possible.
Yeah, they're not as big as possible. They're small. What I do like about them is the delightful way that they've only kissed the curve at one point. That just makes me smile, you know? How romantic. So we got like these two tangents that have kissed the curve at their own separate points. Notice that I could follow the line down and I could tell what time they kissed the curve at. Looks like 3.5 seconds for this one. I'll let you read when this one occurred. And I'm going to ask you, please, based on this graph, I'll zoom out a little bit, but based on this graph, could you answer the questions? The instantaneous velocity at points A, B, and C, and maybe you didn't notice it, but there's a point A there as well. And could you find the average acceleration between points B and C? And you can use the exact same methodology as shown earlier in the lesson for this, except that I've done some of the, or the textbook author has done some of the work for you, okay? So see if you can do this. Work with a buddy. And if you're able to do that, there is a crossword here. See if you can do that one as well. A little bit of fun fact here for you too. All right, go.